Okay, YouTube, in our last video, after exploring inverse functions and their graphs, what we're going to do in this video is essentially find the inverse of these three functions that are given here as numbers 4, 5, and 6. And then we're going to graph those functions and their inverse functions, kind of verify that they are indeed reflected over this line y equals x. We know that the graphs of f of x and f inverse of x are reflected about the line. Given by y equals x. And so we're going to verify this in this video. So let's go ahead and start with number 4 here. We have y equals 2x here. And so our very first maneuver, of course, is to switch our domain and range. We're going to solve for y here. So dividing by 2, we're going to end up with this. We're going to get y equals x over 2. And we're really going to call this f inverse of x. F inverse of x equals x over 2. And I'm going to put a box around this. So we have f of x, which is 2x or 2x plus 0. Now this right here is just a line in y equals mx plus b form. So with the b value like 0, I'm going to go ahead and put that at the y equals 0 mark here. And then we're going to go up 2 over 1 is our slope value. And I'm going to do this just kind of repeatedly here over and over again just to really make sure that I get an accurate graph. We'll go down 2, back 1, down 2, back 1 a couple times. Go ahead and start thinking about your other line here that I'm going to put in gold. But essentially, we say that this is the graph of f of x here. So f of x, we want to make sure we label this also. F of x. So now to graph this other line here, f inverse of x, we say x over 2. We could also write this as 1/2 x. And so you could see how this is 1/2 x plus 0. So it also has a y-intercept of 0, but it goes up 1 over 2. And so like its inverse function here, it starts at 0, 0, but behaves exactly in the exact opposite fashion. Instead of up 2 over 1, it goes up 1 over 2. And so we can see that this is f inverse of x. Ooh, that was pretty slick there. We say f inverse of x. And so what we wanted to verify is that they were indeed reflected about this line here, y equals x, and we can clearly see that here. So going ahead and taking a look at number 5 here, we say what's the inverse of taking something, making it negative, and adding 1? You know, we could say, well, let's go ahead and write this as well. First of all, y equals negative x plus 1. And then what we're going to do is find the inverse, which means start by switching the domain and range. Switch x and y. So x equals negative y plus 1. So to solve for y here, we would subtract 1 from both sides. And we end up with this x minus 1 equals negative y. So now, multiplying or dividing everything by a negative 1, I'm going to use this space up here. I'm going to say y equals, now we get negative x plus 1 when we divide everything by a negative 1. And I'm going to call this f inverse of x. Now f inverse of x is negative x plus 1. And so essentially, when we want to go graph both of these now, well, the original one here really is also a line in slope-intercept form. We say f of x is negative x plus 1. So it hits at positive 1 as our b value, and its slope is negative 1. So we're going to go down 1, right 1, down 1, right 1. And we could do this quite a bit, or we could try to play as best we can to connect the dots, which is what I'm going to do at this point. I'm going to say this is f of x. And so I'm going back up and to the right. Okay, so now graphing f inverse of x, we can see that it has a slope of negative 1 and a y-intercept of 1. So we say f inverse of x here. Let me see here. We subtracted 1 and we divided by a negative 1. Yeah, this looks like it'll work here. It looks like we get positive 1 is its y-intercept and a slope of negative 1. You know, I'm looking at this and something's off. Wait, you know what I notice? These are the same line. And so why is this happening? You know, I want to know, like, why is this line reflected over upon itself? And so we'd say that it is its own inverse, which is a really, really funky thing to say. But if we were to look at this line here, this imaginary line, y equals x, we could clearly see that this graph, if you reflect it over this line, y equals x, just reflects upon itself. And so this is a curious case of it is its own inverse. And so for our last function here, let's go ahead again and start by writing this as y equals 1/3 x minus 2. And we're going to start by switching our domain and range. So x equals 1/3 y minus 2. And so let's go ahead and start by adding 2 to both sides. All right, so we get x plus 2 on the left side, and we're left with 1/3 y on the right. Now the interesting thing about the right side is we're going to multiply by its reciprocal here to get it to be a 1y. but we have to take the left side also times the reciprocal 3 over 1. And so what we end up with here is this. We get 3x plus 6 on the left side equals y. And of course, we're going to call this f inverse of x. And f inverse of x is equal to 3 times x plus 6. And I'll put a box around that. So again, graphing the original function here, f of x, which is 1/3 x minus 2, that has a y-intercept of -2 and a slope of up 1, right 3. So up 1, right 3, up 1, right 3, up 1, right 3. Again, you know, we could go down 1, back 3, down 1, back 3, again, down 1, back 3, and we'd say, okay, well, here's our original function. We're going to label this here f of x. If we were to go graph its inverse function now, which has a y-intercept of 6, we're going to go up 1, 2, 3, 4, 5, 6. Okay. You see this point 0, 6 on its graph. 6, 0 also on this graph over here. Just want to point that out. Basically, we're going to say the slope here is 3. And so, excuse me, what we end up with essentially then is a slope of 3. We'd say down 1, down 3, back 1, down 3, back 1. Sorry to say that, but we say up 3, right 1 would be the same thing as down 3, back 1. I'll do this again here. Down 3, back 1, down 3, back 1. Okay, and so sketching this in, we could see that this is f inverse of x. And so it takes a second to kind of let this sink in here, but if you were to say that the line that hits at a y-intercept of 0 and has a slope of 1, this line right here, this y equals x, are these graphs actually reflected over this line? And we can clearly see that they are. Clearly, this point, negative, I think this is -3, -3 is on there. We can see that there's a good reason why it would have to be, because x equals y. Those are all the points where the x and y values are the same. So that's how graphs are related and how we can verify two things are inverses graphically. Cheers.